Hey everyone, in this lecture, we're going to go over an example of a confidence interval designed for proportions. So let's get started. Alright, so we're going to head over to the computer and work through an example together.
Alright, so it's important to understand that in the last lecture, there was actually something that I mentioned that is written in a way that you probably won't see in a class or a cheat sheet. But last time I put the square root of n in the denominator and p hat times 1 minus p hat in the numerator. Now this is definitely not wrong, but this is unfortunately not how cheat sheets and teachers write this formula. They actually combine this entire fraction into one square root because the numerator and the denominator both are square rooted. So because of that, they write it like this. I personally don't like this, but I tend to get a lot of comments of like, why is your formula different? It's not. It's actually the exact same formula, but it's just written differently in a way that makes more sense to me. This is actually how you're probably going to see it written in some sort of cheat sheet or some lecture from a teacher. It's the same formula, just keep that in mind. Now we're going to go through a very special example that I want to cover. Let's suppose you sample people and you ask them, do you support background checks on guns? And you find that 97% of the people do. And let's say you interview like 23 people. Now, I'm not sure if this is even possible, if you can get 0.97 by interviewing 23 people, but don't worry about it. Let's suppose you round it or something. So you interview 23 people and you find that 97% support background checks. Now let's develop a confidence interval. So you have 0.97 plus or minus 1.96. We're doing a 95% confidence interval. Divided times the square root of, and I'm going to do this in terms of this formula right here. So times 0.97 times 1 minus 0.97, all divided by 23 inside the square root. So let's figure out what that is. 0.97 times 1 minus 0.97 divided by 23, take the square root of that. And very nice, we get 0.036. And then we times that by 1.96 to get our margin of error. By the way, like I said, that entire region right here, this including that z star, there we go, is our margin of error, and this is our estimate right there. So that's the center of the 0.97 is going to be the center of my confidence interval. So I have, this is just 0.97 plus or minus 0.07, which by the way is the region 0.9 and 1.04. Now there's something to say about this confidence interval. If you notice, I'm making the claim with 95% certainty. So this is again 95% confidence interval. Because of this 1.96, by the way. That's how I know. So I'm making the claim that the proportion is somewhere between 90% and 104%. But let's think about that for a second. Is it possible that 104% of the population believes in that there should be federal background checks on guns? Well, that's not possible. The highest proportion of the population that can believe such a thing is 100%. So this is actually correct, but I can actually give more information by just simply saying that the proportion is somewhere between 90% and 100%. And it's much better to write it this way because there's just no reason to make the claim that it could be between 100% and 104%. That's not possible. So because we have those boundaries, let's cut these confidence intervals at the corresponding boundaries. And you might have to do that with some tests every once in a while. That's perfectly fine. Anyways, I hope this helps. I hope this makes sense. Thank you guys so much. I'll see you in the next lecture.
You just watched a video from More Learning. We provide free math videos and we offer many online courses. We also provide free math tutoring via YouTube Live every Thursday and Sunday at 9 p.m. Eastern Time. Make sure to subscribe to our YouTube channel and like this video to get access to all of our free content. And put a comment in the comment section if you have any math questions. Check out all of our courses on amorelearning.org.